Hello dear aspirants, this is Dr. Saurabh Sir's classes. Our contact number is 98367930076. Again, I am repeating our contact number, which is 98367930076. And our email ID is saurabhsirclasses@gmail.com. So if you have any mathematical queries, doubts or anything, so please feel free to contact us. You That means you can call on this number or you can WhatsApp also. Rather, you can drop an email to our email ID, which is written in the screen. Then you can join our regular batches, our one-on-one sessions and our online classes. So that will be beneficial for your preparation of upcoming examinations like ISI, TIFR, NBHM, CMI, GATE, CSIR, NET, etc. So please feel free to contact if you need any help from us. Okay. So now we are going to solve a question which is saying us that suppose x and y are random variables, the conditional expectation of x given y is denoted by expectation of x given y, then our expectation of x given y equals to what? Okay, so this is a not so tough question. Rather, we can write it that. So we are going to determine this thing. That means expectation of this. So we can use the law of total expectation, which is a fundamental property of conditional expectation. So now law of total expectation is what? The law of total expectation states that for any two random variables x and y, we can write that expectation of this thing, that is equals to, rather, that is equals to expectation of x. This means that the expected value of the conditional expectation of x given y is equal to the unconditional expectation of x. So what will be our intuition? Which is our intuition will tell that the conditional expectation, this uh, let me write with another color. Yes, conditional expectation, this is a function of y. We can easily see that, and it represents the expected value of x given the information about y. When we take the expectation of this thing, that means expectation of x given y, then we are essentially averaging out the dependence on y, leaving us with the overall expectation of x. So now we are going to prove this thing. That means this is equals to it is equal to x. Okay. So how can we prove that? So by definition, the conditional expectation, which is this, that is a random variable depends on y. Taking its expectation with respect to y gives expectation of x given y, that is now equals to integral minus infinity to infinity expectation of x given y equals to y, marginal value of this fyy dy. Using the definition of the conditional expectation, we will get expectation of this thing is equals to minus infinity to infinity integral x f restricted to this of x given y dx. So now we are going to substitute it into the previous question. So we will get what? So now if we put this in this, then we will get, let me write it. Yes. So then it will be expectation of x given y, that is equals to minus infinity to infinity, integral minus infinity to infinity x, if restricted to this, of this dx, into that will be fy y dy. Okay, so what can be done here? So now we can take the x outside of it, so then we will get, that is equals to minus infinity to infinity x, then bracket starts with this, so we will get, that will be this thing, and we will get fy y dy, sorry, dy dx, and then the inner integral, that means this thing will be what, this thing will be f, the marginal value of x, so f x x, so then the total integral will be my what, that will be minus in that will be equals to minus infinity to infinity x into this dx. So that is equals to, we all know that that is equals to only expectation of x. Okay. So what will be my correct answer of this question? So the correct answer of this question will be our option A. Okay, so again, I am telling that if you have any other mathematical queries, doubts, or anything, so please feel free to contact us on this number, or you can drop an email to our email ID. So which is classes@gmail.com. So you can enjoy all the services of Dr. Soros's classes. Okay. And I am telling that this question is appeared in the year of 2025 in the GATE data science question paper. Okay. Thank you guys. Hope you understood. Thank you.